This podcast is on the concept of limiting reactants. Just like the reality of making chocolate chip cookies, chemists can also run out of ingredients. And when we run out of something, we say it limits how much we can make. We call that the limiting reagent. Let's look at some cookies. Here's a chocolate chip cookie recipe. If you have 5 eggs and 2 cups of butter, how many cookies can you make? Well, if I used up all the eggs, do the calculations, and I'll discover that I'm going to be able to make 12.5 dozen. You use the ratio of cookies to eggs from the recipe, just like the balanced equation in chemistry. What if I use up all the butter? Well, if I go ahead and use up all the butter, I can make 10 dozen cookies. So which one's limiting? If we use up all of the butter, we can make 10. If we use up all the eggs, we can make 12.5. Well, obviously, we can only make 10 dozen. Since the butter makes fewer cookies, we know it's the limiting reactant and that eggs are in excess, and we're going to have 10 dozen cookies. You can always go ahead and calculate the number of eggs left over, calculate the number of eggs you need stoichiometrically, and do a little subtraction and find we have 1 egg left over. We just want to visualize what a limiting reactant is like. Have a look at this. We're starting out with 8 moles of hydrogen, 5 moles of oxygen, and no water. Now, if the reaction occurs, we're going to find that we go through and we have 7 moles of hydrogen because we lost 2 and 4.5 oxygens. And if you follow this through and watch the numbers, what we're going to find is that we keep using up the hydrogens and the oxygens one at a time. And we're going to get to a point where we've used up all of one of them, and lo and behold, we have oxygen left over. So we say that the hydrogen, because we ran out of it, is the limiting reactant. And we can make 8 moles of water, even though we had enough oxygen to make 10. The limiting reactant determines the amount of product. Let's look at a stoichiometry problem with chemistry. 7.39 grams of aluminum reacts with 18.24 grams of oxygen. How many grams of aluminum oxide are formed? First, we need to determine the moles of aluminum that we're given, and this is done normally. We go through and discover that we have 0.2739 moles. Then determine the moles of oxygen, and go through and find that we have 0.5700 moles of oxygen. Now, how much aluminum oxide could we make if we used up all the aluminum? Straightforward stoichiometry problem, 2 aluminum oxides over 4 aluminums from the balanced equation, and we find we can make 0.137 moles of aluminum oxide. Then you want to determine how much aluminum oxide could we make if all the oxygen was used up, and that comes out to be 0.3800 moles of aluminum oxide. So, using up all the aluminum will make 0.137 moles of aluminum oxide, but using up all the oxygen will make 0.38. Therefore, the limiting reactant is going to be the aluminum. And we're going to make 0.137 moles of aluminum oxide, and so we can calculate that we're going to expect 13.96 grams of aluminum oxide using the stoichiometry like normal. Well, what about the oxygen? We can determine the moles and the mass of oxygen left over. First, of course, we have to find out how much oxygen reacted, and we use our balanced equation for that. We discover that 0.2054 moles of oxygen reacted. We started out with 0.57, so we're going to do the subtraction and discover 0.3646 moles, and when you multiply by the molar mass, we have 11.67 grams of oxygen unreacted. So, just a quick review. Look at the sequence. Balance the equation, convert mass to moles for every reactant you have, determine the mole ratios using the balanced equation, and then use them to calculate the moles of product produced from each reactant. The one that produced the lesser amount is the limiting reactant. You use that moles of product, convert moles to mass, and you have your answer. You can also calculate the moles of excess reactant remaining using your mole ratios, and then you can determine the mass of that unused reactant. And that is limiting reactant stoichiometry.